The problem is basically called arranging books. And what you can do, the problem basically is that you have a lot of S, M's, and L's. So let's give a random configuration, maybe L, 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 S, or nope, I should do text for sure. L, 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 S, S, M, M, L, L, S, M, L, S, M. Let's do some configuration like this. And then what we're going to do now is that we're going to try to swap this. Actually, you know what? I should actually put a space between them. So L, 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 S, S, M, M, L, L, S, M, L, S, M. Cool. All right. So what does this mean? That means that you now have a configuration of numbers, and what you want to do is that you want to shift them, right? Shift them, and then you want to find. Let's see what the final configuration is, right? Because we want the range of books so that L's on the left, so L, 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 M, 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 and S, 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 S. That's the final configuration you want, right? That's how you understand the question, right? So first thing you have to do on any contest, obviously, is to understand the question, and that's basically it, right? We want to go from one configuration and get to the other one, right? And we want to do a series of swaps, right? So swapping two elements, right? So there's find the pen. So there's A and B. You want to swap those, and then you just get B and A, right? So we want to swap them as less times as possible, right? So let's see how we can do this. First of all, we're obviously going to look at the subtasks first. So for the first 9 subtasks, there's only L's and S's. So what you notice is that you can just swap any L's and S's, right? So what happens is that if here, let's say this is supposed to be L and this is supposed to be S, realize that there can only be some books that are unsorted, right? There has to be an S here and an L here. And what you do is if you swap these two, they're going to be sorted, right? So for the first 9, it's kind of a hint for the later problems. That's why the subtasks are important. You look at the S's in L and the L's in S, and you swap them all, right? So let's say there are more S's in here and L's in here. You just swap all of the L's and S's, and at the same point, you're going to end up with, L's on the left side and S's on the right side, and they're going to be all sorted. If there are L's here, don't worry about it. These are already sorted, so just pretend they don't exist, and that's how you get the first 9. So even if you don't know almost nothing, know almost nothing about programming, you can easily get the first 9. Now, how do we get the next 6? This is much harder, and this is what tripped up most people on the junior because it requires a lot of intuition. And if you did this, good for you, because you probably got a really high mark. This year's J4 is actually harder than the J5. I don't know why it's just harder. All right, so how do we fix this? Well, let's look at the same kind of configuration we did before. Well, we have L's here, we have M's here, and we have the S's here, right? So this is L, this is M, and this is S. Now notice that we can do the same thing as before, but we have to do 2 at a time. If you want the intuition for this, you can look at last year's S4, which is swapping seats. It's very similar to this problem. What you can do for, let's say you have an S here, right? Let's say you have an L, you see an S here, and you have an S, L here, you can swap these two, right? And L will now be here, and S will now be here. This is the same pairing swap we did as before, except notice that we're only doing it to L's and S, right? And you have to do 3 of these swaps. You have to do them to L and S, you have to do them to L and M, and you have to do them to S and M, right? So you have 3 of these different types of swaps. And once you do all of these swaps, you're going to see that for every 2 elements, you need to do 1 swap. So if we want to write this using mathematical notation, it's 1/2 of cyclic of LS, LM. And what this means is that we're taking all of the possible pairing swaps, and we're going to divide them by 2. That's the number of swaps you need. Now notice what is going to be left, right? What is going to be left is that you're going to have, let's say this is L, this is M, this is S. What is going to be left? Well, that means that we no longer can have something like this, but we can still have something like this, right? So what if all 3 of them are unsorted? So L, M, and S. What if we have this? Well, this is another special case. But notice that once we take care of all of these, this will be the only possible one that's left. 3 unsorted elements. This was the other important intuition that you saw, right? After the pairings, you see that these are the only left. Now, how do we take care of this? Well, we need 2 swaps, right? Because we fix one of them. First of all, we make one of them, right? So let's say S, right? And then once we swap these, we have L here and S here, and we'll swap these 2 again, right? So we need 2 swaps, right? So now that will be L and that will be M. So notice that we need 2 swaps here to get them right. And for every 3 elements, we need 2 swaps. And again, we need cyclic of LMS. Again, this means that we need to swap all triplets and multiply the number of triplets by 2/3. What is the time complexity for this? Does this work? Well, it does, because each element is only going to be swapped once. Notice that, let's say we swap L, M, and S, this S will be in the correct position. And again, we say that anything in the correct position, you kind of like throw it in the bucket and you just leave it there. So it's always going to be right. So what happens is that whatever you throw in the bucket is going to be right for sure. And then what you have is that you have ON, right, for the for n, where n is equal to number of elements, right? Because every element has to be swapped once. Once it is swapped once, it will definitely be in the correct place, and you don't need to worry about it again. Right, so that's basically time complexity. And the last thing I wanted to mention is a quick solution sketch for the code, right? How do we do this? How do we do the implementation for this? Well, it's actually quite simple. First of all, we want to do this first. Now, how do we do this? We need to find all doubles, pairs that we need to do. So what we need to do is we're going to find all LMs, we're going to find all LSs, and we're going to find all MSs. To do this, we're going to search through and find all of the L's that should be an M, all the L's that should be an S, and all the ones that should be an L but are not, like pairs of LM and ML. So like all pairs of these things, right? We're going to find the pairs first. We're going to divide by 2 and find the minimum, and that's going to be this, right? It's going to be one half of the minimum of LM ML, right? So we just find the minimum of that. That's going to be our first double pairing, right? So then after we have this double pairing of cyclic, we're going to do the same thing here because the rest of them left are going to be the triples. We're going to take the triples of LMS and then all the way down to SML and then work with those, right? So we're going to take 2 over 3 of whatever's left, right? Because when we took the minimum of LM and MS, we already dealt with all of this, right? So whatever is left is 2/3 of that is how many swaps you need to get rid of it, right? So that's basically, and then you just print out the final number of swaps. If you need any more solution sketches or hints for the code, feel free to DM me on Discord. And that's it for J4. Cool.
Okay, now I'm going to be, I think I'm doing the J5. Yeah. So I'm guessing everyone here knows the question, or not. Is it on Dmudge? I'm not even sure if it's on Dmudge. Nope, it's not on Dmudge. Yeah. Martin's still lost. Jerry. Okay, I guess not then. Questions. I don't think I have access to them. Oh, I do have it.
They have been posted onto their Waterloo has officially released the questions.
Oh. Well, okay. Thanks. Wait. Oh, Zoom's blocking my screen. Junior PDF screen to share. Okay, so I think you guys can see this, but like modern art, right? This is the question. Let's read through it. A new and upcoming artist has a unique way to create checkered patterns. The idea is to use an M by N canvas, which is initially entirely black. Then the artist repeatedly chooses a row or column and runs their magic brush along the row or column. The brush changes the color of each cell in the row from black to gold or gold to black. Given the artist's choices, your job is to determine how much gold appears in the pattern determined by these choices. And so your input, you're going to be given the size of your canvas, which the artist paints on. And then you'll be given the number of actions he does, right? And so I don't think the way I did it is actually legit, but I mean, it kind of thinks around the box. So saying you have a canvas like this, right? Since I have grid lines, I'm just going to use that. Whenever you do a strike across, let's say, this board of random size, right? But pretend that this is all black. Now pretend you also just draw a strike across it like this. Then all of those turn into, well, it's supposed to be gold, but yeah, you get the point, right? I'll replace it with white for now. So let's replace the white gold with white, so I don't have to like fuss over the color. But like, yeah, whenever you draw the artist says column and then the number, then you draw a line across the column, changing all of the black nodes to gold and all the gold nodes to black, right? And so if I did this, then in the middle, this would actually be black because it changed from white back to black because you put another stroke over it. Now, this question is very gimmicky because you don't need to actually loop through anything, really. You only need to loop through the actions he gives you. So let's say you have your 3x3 grid, right? That is, let's say, this big. Just Control C that. I'm horrible at this. You have your 3x3 grid. I'm not doing a bigger example because this is very time consuming, but this 3x3 grid, when you draw a strike across it, let's look at their instructions. They say row 1. So all in row 1 turns to yellow. And column 1. Now this turns back and these ones turn to yellow. Now, if you think about it, really, the number of gold tiles is what we're looking for to print out, right? And so to really, you really only need to do 2 calculations in the end. And you also need a set, which is very important, and I'll go over that later. So you have your gold tiles there. I'll turn off the grid lines because it looks ugly, but the only thing you need to do for this question is you need to realize that the number of times you strike the rows, let's say the number, our variable nr, I'm gonna zoom out a little so I can draw better. Let's say the variable nr is how many times we've stroke a row, and let's also assume that it has no repeated actions, right? Because you should filter those out first by going through like a list and seeing every time. I don't know if I'm explaining this well, but like, let's say you do C1 and then later in the input you see C1 again. Then if your array already has C1, like your array of actions, then go back and remove the previous C1 and don't add this one in, because striking over the same row twice really is just, it does nothing, because it just turns it into gold and then turns it back to black. It's useless, right? So you can just cancel those out, which will help speed up your program a lot. And so after we process that, let's say that nr and nc are our variables. So nr representing the number of times the rows have been struck without like repetitions or like bad calculations, and C representing the number of times the columns have been struck. And so really all you need to do once you have that information is you can go result, right, which is your end variable that you can print out, is going to be equal to, so the number of times you stroke the rows is nr, right? Then you multiply that, by the height of your grid times height, right? And that'll give you the number of tiles that striking the rows. Wait, no. I said that wrong. The width, because you're striking the rows. So striking a row is that way. I'm being dumb. That's horizontally strikes. So let's say W represents the width, right? So the number of times you strike the row times the width minus the number of times you strike the rows times the number of times you strike the columns. Does that make sense? Because here, if I put it into this example, you strike here you have nr times width, which is going to equal to that, right? All of that one strike I did, and then minus nr times nc. And since I struck both times once, it's going to do 1 times 1 minus that 1 in the middle, right? And since I haven't accounted for the column struck yet, you just need to go to the, it's going to be in the same line, but like I'm just going to write it here, plus nr nc times the height minus nr times nc. This looks really ugly, but I hope you get it. That's basically all this is the equation you need to solve the entire problem. Do people understand? Does that make sense? Did I explain that well? I'm very fascinating. I know, right? This actually took me half an hour to figure out on the on the coding thing because I was so stressed I couldn't think straight. I was like, wait a minute, I can just multiply these things. If anyone, does anyone need me to go over the variables or anything, or are we like good on this? Because if not, that's the end. That's the solution. Makes sense? Thank you, Martin. Anybody else want to comment on that, or is did everyone just leave their computer on and have CS Club in the background? Okay, I guess that's the case. I hope you understand then, and if you don't, DM me on Discord or like just message me now. It should be simple enough. Matthew, do you understand me?
Yes.
I hope you do. Okay, well then that's the end of the J5. Thank you for coming to my TED Talk. No, it's not a TED Talk.
Amazing TED Talk.
Well, yes, TED Talk.
Okay, so now I will be going through the J1, 2, and 3 because I mean I'm doing all 3 of them because they're all pretty simple, so it shouldn't be too hard. So let me share my screen again. So here you see it, right? So we will start with our very simple first question. I guess I'll let you read it because I don't think I'll zoom out so you can see the entire problem. And I'll give you like a minute to read it. Okay, so I'm assuming everyone has read it so far. So I believe the question here for everyone is pretty simple, right? So you have this equation that they ask you to use, and they'll give. So you have P, then you have 5 times another variable called B, and then minus 400. Then the input specification tells you, they give you what's B. So obviously you would use this equation. So you just do some basic math, do 5 times B minus 400. So now you have what's the pressure, or P, or 90, or in this case, say look at sample 1, yeah, B is 99. So we know that P is equal to 95. So based on how we know that at sea level, atmospheric pressure is 100 kilopascals, then we can easily use a if statement to check. Oh, if it's equal to 100, then we know we're at sea level. If it's less than 95, 100, sorry, less than 100, you're above, and if it's more, then you're below sea level. And so this is pretty simple. You just do some math, then do a comparison. So does anyone not get it or anything? Oh, a way to see your submissions. I believe there is actually. If you log into the CCC grader, you enter the CCC 2021, and it should, at the very bottom, it should have a history of your submissions, and you can click on it.
That was within the contest, though, wasn't it? I'm not sure.
No, you can do it after you did the
Really?
contest.
Okay, well, I'm stupid. Don't listen to me.
Okay, so now moving on to the J2, because no one seems to have any questions. J2 is also pretty simple. I'll give you like a minute to read it. Oh, I guess I was wrong. Oh, okay. I see why.
Okay, never mind. Listen to me then. Matthew's being dumb.
Okay, now, so I guess when the contest was still technically, how should you say it? Live, which means the period that was available. It was available for a period, I believe, 3 days, and then during that 3-day period, you can access your submissions even if after you've done the contest. But I believe after the live live time period, it will just close and it will remove all of them. All right. Since has anybody not finished reading it? Since there's no response, I'm going to assume everyone has read this. So it's also pretty simple. You just do a pretty simple, just keep track of who has the highest bid and who is the name, what's their name. They just do a easy like loop through all the different names and values, and you're keeping and then comparing to what's the highest one stored to see if it's higher. Then you replace the highest value and then change the name of the winner. Then you just do something like that. But I'll point out something very important, because see how in this question it says if there's a tie, whoever placed their bid first wins. So in this case, when you do a comparison to what's the next person's bid, make sure it has to be specific, only higher, not equal, because equal, then still the first person who bid wins. So you have to do specifically higher in order to solve this problem. So that's about all you need to really do for the J2. If you have any questions, you can ask it now. Since no one has any problems, I'll just go to the J3. And once again, I'll give you a little time to read it. Since I gave you a few minutes, so I assume everyone has read it. If you haven't, then I'll give you a little bit more time. But since no one's talking, I'll assume everyone's read it. So this, once again, what J1, 2, and 3 are all generally pretty simple here. So now you have this 5-digit numbers, and then by the different digits, you can figure it has specific instructions. And you also, this is a little more complicated because you have to store previous values, but it's still generally quite simple. So for say for the sample input, 5, 7, 2, 3, 4. You will obviously want to take this in as a string because that makes it either access specific digits. Then we know for checking if something even or odd, we only need to look at the last digit. We don't really care about any other ones. So we can just look at the second digit of this and check whether it's odd or even, and then we can choose a direction. And if we know it's 0, we can just check the first digit to make sure it's also if it's also 0. If it's also 0, then you have to use the same as the previous instruction. So we should create a variable here as we're going through the different secret instructions to keep track of what the previous one was. And you don't really need to worry about if to say the first one is 0, because it guarantees you that the first line will not begin with 0, 0. So just use a while loop, have a pretty simple variable to keep track of what was the previous one, and then just use a string and just access different location, check if something is even or odd. You can do this by saying turn the string into an integer and seeing if it's even or odd, or you can see if the last digit's in a string of only odd digits or something like that. And then you can check the direction, and then you can find how many steps you take in that direction just by doing a simple substring of it. And that's a kind of and that's basically pretty simple way of explaining how to do this problem. And that's literally about it for the J3.